Right now, somewhere on this planet, the ground is shaking in a way scientists cannot fully explain. Not one earthquake, not two. Entire swarms of them, hundreds at a time, hitting the same small patch of Earth over and over again in a matter of weeks. In the last few months alone, 3 separate regions on Earth have lit up with this exact kind of activity. And when you line up what happened in each one, the pattern is hard to ignore. Stick with me for the next few minutes, because by the end of this video you will understand exactly what an earthquake swarm is, why it is different from a normal quake, and why some of the world's top seismologists are watching these clusters more closely than ever before. Before we go further, if you are new here, welcome to Universe Proof, the channel where we break down the biggest mysteries happening on our planet and beyond using real science instead of guesswork. Today, we are digging into a phenomenon that sounds small on paper but has a track record of surprising entire cities. An earthquake swarm is not just a string of aftershocks following one big quake. It is a cluster of small to moderate earthquakes that erupt in the same area, close together in time, without a single dominant main shock leading the pack. Sometimes it is dozens of tremors, sometimes it is thousands. To understand why this matters, picture a normal earthquake sequence like a single loud bang followed by a fading series of echoes, each one weaker than the last. A swarm behaves completely differently. There is no clear big one at the start. Instead, you get wave after wave of similarly sized shaking, sometimes stretching on for days, weeks, or in rare cases, months. Scientists have learned that these swarms usually mean one of two things is happening underground. Either stress is slowly redistributing along a fault system, or fluid, sometimes water, sometimes molten rock, is forcing its way through cracks deep beneath the surface. That second possibility, magma or fluid movement, is exactly what makes swarms so interesting to researchers, and honestly, a little unsettling too. When magma pushes upward through rock, it does not move smoothly. It cracks and fractures the ground around it as it goes, and every one of those tiny fractures can register as its own small earthquake. String enough of those together, and you get a swarm. This is why volcanologists treat certain swarms as an early warning sign worth watching, even when each individual quake barely rattles a coffee cup. Now let's talk about what actually happened this year, because this is not a hypothetical thought experiment. In one recent case, Southern California's Cozo volcanic field lit up with a fresh swarm of earthquakes, an area already known for its geothermal activity and its history of shaking in response to nearby fault ruptures. Researchers monitoring the region noted that this kind of clustering is not new for Cozo, but they still keep a close eye on it, watching for any sign of ground deformation that might hint at something bigger stirring underneath. Just months before that, Southern California saw another dramatic swarm, this time in Imperial County, where residents felt hundreds of tremors hit their neighborhood in a single weekend. Over 400 earthquakes were recorded in that cluster alone, including one strong enough to rattle windows and nerves across the region. Local seismologists were quick to explain that this particular corner of California is famous for producing swarms like this, but try telling that to someone standing in their kitchen while the shelves are shaking for the third time in an hour. Around the same window of time, a very different swarm broke out in Utah, in a rural stretch of Millard County near the town of Kanosh. In the span of just one day, more than 30 individual earthquakes were recorded there, the strongest reaching a magnitude that was easily felt by nearby residents. Geologists tied this activity to Utah's Intermountain Seismic Belt, a stretch of crust that is literally being pulled apart as tectonic forces slowly widen the American West, a process that has been building for millions of years and shows no sign of stopping anytime soon. So here we have 3 separate swarms, in 3 completely different states, all within a tight window of time. On the surface, that already sounds like something out of a disaster movie. But before you start stockpiling supplies, it is worth remembering that earthquake swarms are actually a normal part of how our restless planet behaves. Geologists have documented swarms for over a century in places like Yellowstone, the Salton Sea, and parts of Japan, and the vast majority of them fizzle out without ever producing a major damaging earthquake. But here is where the story gets genuinely fascinating, and where I want you to lean in a little closer. Not every swarm stays small. In early 2025, the Greek island of Santorini experienced one of the most dramatic swarms ever recorded in that part of the world. Over the course of just a few weeks, more than 28,000 individual earthquakes rattled the region surrounding the island, an almost unbelievable number when you stop to actually picture it happening in real time to real people living their normal lives. What made the Santorini swarm so significant was not just the sheer quantity of quakes, but what scientists later discovered was driving it. Researchers found that months before the shaking even began, magma had already started quietly accumulating in a shallow underground reservoir, slowly pushing the island upward by a few centimeters, an amount too small for anyone to notice just by walking around. Then, as more magma pushed up from deeper levels, the seismic activity exploded, And the cluster of earthquakes actually migrated more than 10 kilometers away from the island itself. Residents on Santorini did not know at first whether they were dealing with a purely tectonic event or the early stirrings of volcanic unrest. And honestly, that uncertainty was almost as unsettling as the shaking itself. Thousands of people left the island as a precaution, while scientists scrambled to figure out what was really happening beneath their feet. In the end, the swarm gradually quieted down without triggering a major eruption, but it left researchers with an incredibly detailed case study in exactly how a slow, invisible buildup of pressure can suddenly erupt into tens of thousands of earthquakes in a matter of weeks. That is the part that should stick with you. Santorini proves that a swarm which starts out looking routine can, under the right underground conditions, escalate into something historic almost without warning. And that is precisely why seismologists do not simply shrug off every new swarm as background noise, even when the individual quakes feel small and forgettable. Each cluster gets logged, measured, and compared against decades of past behavior. Because sometimes the difference between an ordinary swarm and a genuine warning sign only becomes obvious after the fact. So how do scientists actually tell the difference in real time? Before hindsight makes everything obvious. They look at a handful of key clues. First, depth. Shallow swarms, especially ones tied to volcanic or geothermal regions, get watched more closely than deep tectonic swarms because shallow activity is more likely to be connected to fluid or magma movement near the surface. Second, migration. If earthquakes in a swarm start marching steadily in one direction over time, the way the Santorini cluster did, that pattern can indicate that something, usually fluid, is physically forcing its way through the crust rather than the rock simply settling old stress. Third, and maybe most importantly, scientists watch for ground deformation, meaning any physical swelling, tilting, or shifting of the land surface itself. This is usually measured using GPS stations and satellite radar, technology sensitive enough to detect the ground rising by just a few millimeters. When a swarm shows up alongside real ground deformation, that combination gets far more attention than either signal would on its own, because together they suggest something is physically pushing up from below, not just settling old cracks in the rock. It is worth pausing here to say clearly that most swarms, including the ones we just talked about in California and Utah, show no signs of that kind of deformation. And officials in both regions confirmed there was no elevated risk of a larger, more destructive earthquake following the shaking. That is genuinely reassuring news, and it is exactly the kind of nuance that often gets lost when headlines scream about a sudden cluster of quakes hitting somewhere new. The ground shaking a lot does not automatically mean something catastrophic is coming. At the same time, it would be a mistake to treat every swarm as guaranteed to be harmless just because most of them are. Scientists themselves openly admit that swarms remain genuinely difficult to forecast, precisely because the underlying mechanisms, whether it is fluid migration, magma intrusion, or simple stress redistribution along a fault, can look remarkably similar from the outside in their earliest stages. That uncertainty is not a flaw in the science. It is an honest reflection of just how complex the crust beneath our feet actually is, even with all our modern instruments watching it around the clock. This is exactly why events like the one in Kanosh get logged so meticulously, even when nothing dramatic follows. Every swarm adds another data point to an enormous growing library of underground behavior, helping researchers build sharper models for what typically happens before things escalate and what typically does not. It is slow, patient, unglamorous work, but it is also the exact same kind of long-term monitoring that eventually allowed scientists to piece together the full story behind what really happened at Santorini months after the shaking had already stopped. So should you be worried the next time you hear about an earthquake swarm hitting somewhere near you? Realistically, no, not in the sense of dropping everything and panicking. The overwhelming majority of swarms fade out on their own, exactly the way the California and Utah clusters did this year. But should you find it fascinating, maybe even a little bit thrilling, that our planet is constantly generating these strange, clustered bursts of movement deep beneath the surface, often for reasons we are still working to fully understand? Absolutely, and that is exactly why we cover stories like this one here on Universe Proof. What makes earthquake swarms such a compelling subject is that they sit right at the intersection of predictable science and genuine mystery. We understand the broad mechanisms driving them extremely well at this point. Fault stress, fluid migration, magma intrusion, these are not new concepts to modern seismology. But predicting exactly when, where, and how intensely the next swarm will strike remains stubbornly difficult, even with satellites, GPS networks, and dense arrays of seismometers listening to the ground 24 hours a day, 7 days a week, without a single break. And that unpredictability is really the whole point of this video. 3 different swarms in 3 very different geological settings, all within a tight stretch of time, is not some rare, once-in-a-lifetime coincidence. It is a snapshot of how genuinely active our planet remains at all times, even during the long, quiet stretches when nothing seems to be happening on the surface. Beneath our feet, rock is constantly grinding, fluid is constantly shifting, and pressure is constantly building and releasing in ways we are only just beginning to fully map out. If this kind of deep dive into what is actually happening beneath the surface of our planet is something you find genuinely interesting, this channel is going to be a great fit for you going forward. We regularly break down exactly this type of story, taking real, current scientific events and explaining what they actually mean in plain, simple language without the exaggeration and clickbait you often find scattered everywhere else across the internet. Before you go, I want to ask you 2 quick favors. First, drop a comment down below and tell me which of these 3 swarms surprised you the most, California, Utah, or the Santorini story from Greece. I read every single comment, and I love seeing which parts of these stories stick with people the most after watching. Second, if you learned something new today, share this video with one person who would find it just as fascinating as you did. It genuinely helps this channel grow, and it costs you absolutely nothing but a few seconds of your time. The earth beneath us is far from silent. It is constantly whispering, cracking, and occasionally shouting through swarms just like the ones we covered today. Some of those whispers fade away without consequence. A few, like Santorini, turn into something the entire world ends up watching closely. The only way to know which kind you're witnessing in real time is to keep watching, keep measuring, and keep asking the kinds of questions we just asked together in this video. Thanks for spending this time with me here on Universe Proof, and I will see you in the next one.